Stoichiometry problem. We're comparing one chemical to another, so it has to be done mole to mole. And if we look at our problem statement, we see that we're given means to calculate the number of moles of two different reagents, and therefore we know that this is a limiting reagent problem. We're going to set up a BCA table, but the values that we enter into the table have to be in moles. So we're going to need to determine the formula weight, and following that, the number of moles of each of these reagents. All right, we've calculated the moles of each of the reagents. First, we remind ourselves that oxygen gas is found as a diatomic and hydrogen is also found as a diatomic. So we need to incorporate that when we determine our formula weights. So we've calculated the moles of each and entered them into the BCA table. Looking at our problem, we see we'd need about 2.6 moles of H2 to consume all of the oxygen. And that's because we have 1.3 moles of oxygen, but our balanced chemical equation tells us we need 2 moles to consume each mole of oxygen. So we need about 2.6 moles to consume all of the oxygen. We don't have enough, and therefore we know that H2 is our limiting reagent, meaning it's going to be completely consumed so that we don't have any at the end of the reaction. All right, so if we lose all of our H2 so that none of it remains, we know we're going to lose that much of O2 multiplied by some mole-to-mole ratio. And also we'll be gaining that amount of our product, also taking into account some mole-to-mole ratio. The mole-to-mole ratio we get by looking at our coefficients in the balanced chemical equation. For the top number, we look at the coefficient associated with that item of interest. In this case, it would be a 1, and the denominator comes from the limiting reagent. So our mole-to-mole ratio would be 1/2 or 1 to 2 for oxygen. For water, the numerator is going to come from our entity of interest, the water, 2, and the denominator is again going to come from the limiting reagent. So we find that we gain the same amount of water in terms of moles that we lose of the H2. Now, to find our final values in the BCA table, we add the before plus the change. Before plus the change gives us the after. And note that we're losing reagents and we are gaining products. All right, so we know that we now have left 0.345 moles of oxygen and 1.93 moles of water. Again, we got these values from taking our initial value and adding our change. So this is 1.31 minus 1.93 times 1/2, and we end up with 0.345. 0 plus 1.93 is 1.93. We want to find how much we have in terms of mass of each of these entities, so we're going to have to multiply by the formula weight. All right, so here we've finished the problem. These are the moles that we have at the end of the reaction. So after the reaction is complete, we have 0 grams of H2 because that's our limiting reagent. It was completely consumed. We get our grams of each of O2 and water by multiplying the number of moles times the formula weight. And we remind ourselves we're limited to 2 sig figs, so we have 11 grams of oxygen, 35 grams of water.